All right, we are sharing now. This is going to be our graph for the moment. Three groups of students test how far a toy car would travel down ramps elevated to various heights starting at 5 centimeters. Okay, the results are below. So, independent variable, we need to think, what can we change? What is changing? Well, we've done this in science classes that you've taken before. This first question, or this first thing that's changing is going to be ramp height. 5 centimeters, 10 centimeters. So, yeah, that's what we choose to change. That's our independent variable. Our dependent variable, it says how far a toy car would travel down ramps. So our independent variable is going to be ramp height, and it always helps. I found that if the teacher would write it, I'd understand it better. Independent variable is going to be ramp height, or from the height that we drop it. Dependent variable, that's going to be how far the toy car travels, or distance traveled. So if we go through and we think cause and effect statement, as the ramp height goes up, what's going to happen to the distance that it travels? The distance that it travels goes up as well. So that's what you should say this data table or this graph is about. All right, it says, according to the results, which ramp height resulted in the largest distance traveled by the toy cars? Well, that's obvious. That's this one down here. If we set up our ramp and we go really high, by the time that it reaches the bottom, it's going to travel a further distance. And that helps with our cause and effect statement. I would like to put that one right here. So as height goes up, distance goes up. And that makes sense. So find the one that has the highest height. Number two groups have similar data. One group has data that stands out. Which two groups have similar data? Which group stands out? So which one has data that's similar? Well, guys, we've done this several times throughout the year. We've done that with the ninth graders. We've done that with the eighth graders. If we go through and we look at the data, group 1, 55, 66, 56, 64, 74, that's a good number, 66. I'm noticing that group 1 and group 3 are similar. So it's always good to write down what we notice. Group 1 and 3 are similar. Group 2 stands out. All right, so maybe group 2 did it differently than group 1 and 3. Maybe they were dealing with something different that the teacher gave them. Whatever the case may be, group 1 and group 3 were similar. Group 2 was a little bit different. Based on the data, how far do you estimate a toy car might travel if the ramp height were 25 centimeters? Oh, guys, this is a really cool one. This is where we are taking information and we're using it to think critically. So let's just go with group 3. Group 3 is kind of the middle. It's a little bit less than group 2. It's a little bit more than group 1. This is kind of our median. So 56, when I add 5, it went up 10. When I add 5, it went up 7. When I add 5, it went up 11. So let's add 10. So based on the data, how far do you estimate a toy car might travel? Well, this is added about 10 each time. Right here, add 10 to it, 95. If you wanted to take a different approach, you could say something to the effect of, and remember our cause and effect statement, as height goes up, distance traveled goes up, ... If these guys are going up 7 and 7 and then 8 and then 11, we know that it at least has to be more than 7. So if it's more than 7 for this one, that's going to be 85. If it's going to go up 8 on this one, that's going to be 99. This one up 11, 95. So we're going to say if we were to increase the height to 25, we would anticipate or expect growth. So we're going to anticipate growth. I'm going to guess about 95. This one's going to be 85, 88. So anywhere between 88 and 95 is my best guess. And why did I do that? I went back to the few and I said, what's the difference between this and this? What's the difference between 15 and 20? What's the difference between 15 and 20? This one up 7, this one up 7, this one up 11. So you're not going to go wrong as long as you're able to say why. And I'm saying if we increase the height, we're going to have growth in the numbers. So I'm anticipating about 95. That's question 3. Question 4. List 3 materials used during this experiment. Well, how would you measure the height? You'd probably want a ruler. How would you measure? You're going to need a toy car. And what did we do for our class to increase height? They're over behind my desk. They're pink. Books. So this is getting you guys to think, how could we run this experiment? And it's just going to be, you'd need cars, you'd need rulers, you'd need books. This is having you be the scientist. Last but not least, describe the relationship between the ramp height and the distance traveled by the toy car. Well, guys, that's our cause and effect statement. And we've done that a few times now. So our height and our distance traveled, let's say it one more time. As height, because that's what we change, as independent up, down, dependent up, down. Well, our independent is the height, dependent is the distance. So as height goes up, the distance goes up. That has been a great time talking with you. Thank you for your time, and I hope this makes sense. See ya.